Hello students. So we will continue with the same chapter, that is force and pressure. So today we will discuss about pressure exerted by liquids. In the previous class we discussed in general about pressure, what is pressure. So today we will discuss pressure exerted by liquids. Now the substances such as water, oil, alcohol, petrol and mercury are all liquids. All the liquids exert pressure on the base and the walls of the container. Yes. If you will take any liquid, what are liquids? Liquids which can flow. So if you will take a liquid in any container or a vessel, let us say in glass, so that will exert pressure at the bottom as well as the side of the glass. Now just see here, suppose this is, now here students see here, though pressure is exerted by all the liquids, but since water is the most common liquid around us, therefore we will be using water as a liquid in the activities on pressure exerted by liquids. You know, all the liquids they exert pressure, but we will take water because it's a very common liquid. Okay, now suppose this is a container. The vessel in which liquids are taken is also called as a container. Now suppose this is water. Okay, suppose water is taken, so this is the bottom of the container, bottom of the vessel. So this, all this liquid, whole of this liquid, it will exert weight, which can also be called as force. Okay, at the bottom here, how much force is exerted? The force, the weight of whole of this liquid will be that is exerted at the bottom and also on the sides of the container. So per unit area, that will be pressure. So liquids, it exerts pressure at the bottom and the side of the container. You can see here all the liquids. Yes, same thing is given here. So please underline that liquids exert pressure on the base of the vessel. This is the base of the vessel, okay, in which the liquid is kept, and also the sides of the container. This figure 24 shows the vessel containing a liquid in it. The weight of the liquid pushes on the base of the vessel and exerts a pressure on the base of the vessel. Yes, suppose this is just, that's what I told you just now. Suppose this is the vessel, which is also called as a container, and here water is taken. So whole of this water has some weight. So that weight is exerted here or no? This is the bottom, the base. So the weight of this water, that is exerted, which you can also say a force, okay, that is exerted at the base of the bottom, and per unit area it is pressure, and it is also exerted on the sides of the container. That I will just tell you now. Please note that the vessel in the liquid is kept is also known as container. Okay, dependence of pressure on depth in a liquid. The pressure in the liquid is not the same at all depths. The pressure exerted by the liquid changes with the depth in the liquid. Actually, the pressure exerted by the liquid, please underline, increases with increasing depth inside the liquid. So as the depth increases, the pressure also increases. Why? Because the weight of the liquid increases. The pressure exerted by the liquid is small, just under the surface of the water, the surface of the liquid, but as we go deeper in the liquid, the pressure of the liquid increases. It's very easy. See here, okay, suppose this is the vessel. So let me say this is the liquid. Now what will happen? Here the pressure will be less. Now you increase, pressure will be more, pressure will be more. So depth is increasing or no? So before, why pressure is more? Because pressure is equal to force upon area. Now here what is the force? Force is the weight of the liquid. Force is the weight of the liquid. Now again, okay, now see this example. Now what will happen? This is the liquid. So this whole of the weight of this liquid is exerted at the base. This weight is equal to force. So here the force is more, pressure will be more per unit area. Now what will happen? Now if you take another example, take this example. Now let me say, actually students, this is the same vessel, okay? So now if the liquid is still here, what will happen? The way here, what is happening? The weight of the liquid has reduced, is less. Okay, now the force exerted on the at the bottom will also be less. The force exerted at the base will be less. So pressure will be less or no? So what happens? The pressure, it increases with the depth. Okay, understood or no? So here if you take, okay, you see here if you take this case here, at this point the pressure will be less, because only this much weight is exerted on this portion. Here the pressure will be more, because now the weight of the water column has increased. Okay, and the what is weight? Weight is force, so pressure will be more. Here again this much weight is exerted, or you can say this here weight is equal to force, so the force is increased, pressure will increase. Okay, now so just underline, the depth of the liquid increases, the weight of the liquid column pushing down from above increases. Obviously if the depth is increasing, the weight of the liquid column pushing it also increases. For example, if you see this activity, it's very simple. You take this vessel, in this vessel you make 3 holes here, okay, A, B and C, and you put water. You will see that what will happen? The water will come out from these holes, and you will see the water from this hole C will go far away, then followed by B and A. Why it is going far away? Because here the pressure is more, it is moving with more pressure compared to B and A, so that is why it goes far away. So what does it says? Now here if you take this portion, okay, if you take here, so this much weight is exerted here, understood? So the weight of more water column is exerted. So more force is exerted, that is why water it moves out with pressure. Here only the weight of this much water is exerted, or only this much force is exerted, and so the pressure is reduced. And here the lesser weight is exerted, so again the pressure is reduced. And on the surface, so there is no pressure. So you can see this one, and you will also see that these openings are present at the wall of the container. So this also shows that the liquid exert pressure on the wall of the container. So that is why the pressure just below the surface of the liquid is less. Okay, see here, the pressure exerted by the liquid is small just under the surface of the liquid, but as we go deeper in the liquid, the pressure of the liquid increases. Why it increases? Because the weight of the liquid increases, which is equal to force, and the pressure per unit area. Pressure is what? Force per unit area. So that also increases, because as you go deeper, what is increasing? The weight of the liquid above is increasing, and that weight you can say is equal to force. So force as a whole is increasing, so force per unit area will also increase, so thereby pressure is also increasing. Actually, as the depth of the liquid increases, the weight of the water column resulting from the above increasing, and hence the pressure also increases. Okay, so this is what I have explained you. Please underline, pressure of the liquid increases with depth. In other words, the pressure, the greater the depth of the point in a liquid, the greater is the pressure. Okay, thus the pressure of water will be lesser at depth 10 meters below the surface of sea, but it will be more at the depth of 20 meters. Okay, because now the more water is present and the weight increases, which is equal to force. Now that all, please underline, liquid also exert pressure on the walls of the vessel in which they are stored. The sideway pressure exerted by liquid also increases with the depth of the liquid. Yes. Okay. Now please underline the, now you know that here at the surface the pressure is maximum even at the sides of the container, because so much of weight of the water is exerted, which is equal to the force at the side of the container at, you can say, opening C. So that is why the students, the wall of the dam, please underline, the wall of the dam is made thicker at the bottom. Why? Because of high pressure at the bottom. So it is made thicker at the bottom than at the top, so as to tolerate very high sideway pressure exerted by the deep water stored in the reservoir of dam. Understood or no? Now this is also again the same activity. It's very easy. Now you take this, what you say, container. Here you please fix a balloon, you can say, okay, which is not inflated. Now you add water here. Now when you will add water, what is happening? This much weight, okay, this much weight of the water is exerted here on the balloon. This much weight, you can say, is force, okay, is exerted, so balloon will inflate. Now you fill more, add more water. So now what is happening? The amount of water is increased, thereby increasing the weight of the water, okay. So now the weight of the water has increased, and now this much water is exerting weight on the balloon, and the balloon will inflate. Understood or no? So you can also say that this, okay, that I will just let you know. Okay, please underline. Rabashi demonstrate that the water poured in on the bottom of the container. This is because water container. Okay, this one. So please underline. So this activity shows a liquid exert pressure on the bottom of the container. You know, it exert pressure at the bottom as well as the sides also. Okay, the pressure exerted by the liquid depends on the height of the liquid column. Above the bottom, yes. Now the pressure, now see, liquid exert pressure at the bottom as well as the sides. Okay, now we can also say that the pressure exerted by the liquid depends on the height, because see, before the height was what? This was the height of the water column above the base. This much is the height of the water column or no? This much. Okay, so this much weight is exerted, and now the height is increased. Height of what is increased? Height of water column is increased or no? Height of water column above the base of the vessel is increased. So thereby the pressure is also increased. So if the height of the water column is increased, the weight is increased, or you can say the force is increased. So please underline the pressure the liquid exert pressure at the bottom as well as the sides of the container, and the pressure exerted by the liquid depends on the height of the liquid column. Okay, height of the liquid column. So here the height was less, pressure was less. So as the height is increasing, what is increasing? The amount of water is increasing. So the weight will also increase and the force will also increase. So this activity we have already done. Now this activity, you see, third one. Activity to demonstrate that liquid, it exerts equal pressure at the same depth. Now suppose this is the depth. Okay, it is same. So on both the sides, on the sides, it will exert same pressure, because here there is opening, here also there is an opening, and what will happen? The water will come out from both the openings, and the distance covered by the water on both the sides will be same, which shows that the pressure is same. Okay. The formation of fountain of water from a leaking pipes or water supply pipeline tells us that water exerts pressure on the wall of the container. Yes, sometimes you see that the water pipe, it bursts, it leaks, okay, from the sideways the water comes out like a fountain. So it shows that the pressure, water exerts pressure on the walls of the container, okay. Container, they are the walls of water carrying pipes, okay. So water carrying pipes, the sides are the walls, so they are if the water comes out with force, so that means it exerts the pressure on the walls of the pipe, and the pipe bursts and the water comes out like a fountain. Okay, so pressure exerted by gases. Now students, the pressure is also exerted by gases. Now hydrogen, helium, oxygen, nitrogen, carbon dioxide, they all are gases, and all the gases exerts pressure, okay, on the walls of the container and also at the bottom of the container. The pressure is exerted by all the gases, but since air is the most common gas, so we will consider air in all the activities, okay. Now students, you know air is a mixture of gases. Now you know the gases are made up of tiny particles. You know, suppose if this is a gas, so it is made up of these tiny particles, and here the particles are far from each other and they move freely. They collide with each other and they also collide. Suppose if this is the container and these are the particles of gases, okay, this is the gas, these are the gases particles which move freely, and by doing so they collide, they strike with one another and also with the walls of the container, and this is called as the pressure of the gas. Pressure of the gas is when the particles of the gas, they collide with the walls of the container, they exert pressure on the wall of the container. All the gases are made up of tiny particles called molecules which move around quickly in all the direction. The fast moving gas molecules collide with one another also and with the walls of the container, okay, in which they are kept. When the fast moving gas molecules collide with the walls of the container, they exert a force on the walls of a container. Okay, so they collide with one another and they also collide with this wall of the container. And when they collide with wall of the container, what happens? This molecule is colliding. These molecules are colliding with the wall of the container. So what happens? What will happen? When it will collide like this, it will exert a force on the wall of the container. Here you can say, so they are colliding, so they are exerting the force on the walls of the container, and they also collide among themselves, they also collide with one another. Understood or no? This force produces gas pressure or air pressure, okay, and this produces the pressure. It collides with the walls of the container and it exerts force, and force per unit area is called as the pressure. So hence force produces gas pressure. Air pressure arises due to the constant collision of the tiny molecules of gases present in the air with the walls of the container in which it is contained. So what is air pressure? Air pressure is what? When the particles of the air, it collides with the walls of the container or the vessel in which it is present or enclosed. Now if a certain mass of air is compressed into smaller volume, say by using a pump, then the number of collisions of the air molecules per unit area increases and hence the pressure exerted by the air goes up. And if the container of the air has stretchable walls like a rubber balloon, then higher pressure exerted by the air inflates the container and makes it look bigger. This point will become clearer. It's very simple, students. Now see here. If this is a container, these are the gas particles. They have occupied this much space, okay. So here the per unit pressure will be less, or definitely they will collide with the walls of the container, let us say here. But still what is happening? It is occupying so much of space. So per unit area the pressure will be less, force will be less per unit area. Okay, now the same particles, when it is compressed, means when they are brought together by using some pump, what will happen? Here the particles will come closer to each other or no? They will occupy small space, okay, they will occupy less space and they will come closer to each other. So when they will come closer to each other, they will collide with each other more faster and also with the walls of the container or no? So what will happen? The pressure, gas pressure will increase or no? Here the space occupied by them was this much and they collide with one another but not so fast. So and they also collide with the walls of the container and exert force, but the force exerted per unit area or the pressure is less. But when whole of this gas is compressed means when the particles of the gas are brought together, what will happen? All of these gas particles are brought together, then they will occupy small area, but they will be very close to each other. So collision will be fast and harder and stronger, and the pressure will be more or no, because now the force is exerted on the smaller area and more. So per unit area it will be more. Okay. Now take a rubber balloon and now fill the air into the fill the air into it with mouth. We will find that on filling the air, the balloon gets inflated. Why it gets inflated? When we fill air in the balloon, so in the air, what is present? Particles are present or no? So air particles, they collide with one another, and they also collide with the walls of the balloon, and it exerts force on the walls of the balloon or pressure on the walls of the balloon. What happens? The balloon, it inflates, it gets inflated. We will find that on filling the air, the balloon gets inflated. This can be explained as follow. When we put a lot of air in the balloon, then the number of gas molecules in the balloon, increases too much. The large number of gas molecules causes too many collisions with the walls of the balloon from inside and create a high air pressure. This high air pressure produced by the gas molecules on the walls of the balloon causes it to expand and get inflated. Yes, when you fill the air in the balloon, what happens? It gets inflated because the particles collide with one another and also with the walls of the balloon, and it exerts pressure and the balloon gets inflated. When the air is pumped into the bicycle tube by using a pump, what happens? The air is filled inside, the air particles, they collide with each other and also with the wall of the bicycle tube, thereby exerting a pressure. See here, the bicycle tube gets inflated due to the air pressure exerted by the collision of the gas molecules in air with the inner walls of the rubber tube. The air pressure in the bicycle tube makes the bicycle tire feel hard. So easy. So when you fill the air in the bicycle tube by a pump, what you are actually inserting, what is going inside the air, and that air particles collide with each other and also with the walls of the bicycle tube, thereby exerting a pressure on it, and it gets inflated. Okay. The air pressure which we have just described is due to the motion of the molecule of gases present in the air, which is enclosed in a container like balloon, football. We will not describe another type of a pressure called atmospheric pressure, which is due to the weight of the air present in the atmosphere above the surface of the earth. So atmospheric pressure we will do in next class. What is atmospheric pressure? It is the pressure of the, now what we have discussed, the pressure of the air in the enclosed container, the containers which are closed, like balloon, it is closed, like football, it is closed, bicycle tube, it is closed. Now we will discuss about the pressure of the air, it called atmospheric pressure, which is due to the weight of the air present in the atmosphere. Okay, so till now we discussed the air pressure in enclosed containers, but now we will discuss about the pressure or the weight of the air present in the atmosphere above the surface of the earth. Okay, so we will do till here, and page number 208, please mark the homework. Question number 2. Do question number 2, then question number 17. Question number 2 and question number 17. Okay, students. So thank you. Have a nice